Welcome to qnawire.
Problem. We are told that typically 13% of the colors in the M&M bag are brown, red, 14% are yellow, 16% are green, 20% are orange, and 24% are blue in this particular case. And so we're just trying to figure out different probabilities, and this particular probability question is asking us if we were to grab a handful of 12 M&Ms out of a bag with our hands, what would be the odds of drawing 2 of each color? So you got to think real quick. Okay, there are 6 different colors, so 2 times 6 is 12. So those each are going to end up being what we call our X1s, because we're going to be using the principle from this lesson, this formula from the lesson. And so in order to do this formula, we need a few pieces of information. First of all, the N. N happens to be 12 because it was a sample of 12. We need our X's, so X1 all the way to X6 happens to be 2 because we are drawing 2 of each particular color. So X1 could represent the brown if we want, the X2 could represent the red if we want, and so on. It's just whatever your preference is. But either way, they're all going to equal 2 because we're all trying to get an equal amount of each color in this particular problem. So X3 equals 2, X4 equals 2. Oops. X5 equals 2, and X6 equals 2. Like I said, you can assign each color to be X1, X2, so on. That actually might be a little bit better. So I'll say BR for brown, R for this one, Y, G, O, and then B for blue. Okay, so that's all part of the formula, but then so is knowing the probabilities. So we call them P1 through P6, and it's the probability that corresponds with the particular color and our X1. So notice how I have P sub 1 and X sub 1. Those have to correspond. So the probability of getting a brown, we will say, is 0.13. So notice I turned that 13% into a decimal. That's going to be what you're going to want to do for all of them. So P2 for the red is going to correspond, and it's going to be 13. P3, the probability of that getting a yellow is 0.14. P4 is equal to 0.16. P5 is equal to 0.2. And P6 for the blue is equal to 0.24. All right, so we have all of this information, and now we're ready to finally plug into our formula. So our formula is P, big capital P of X, and we need to start off with the n factorial on top of a fraction. So in this case, our n is 12. So we got 12 factorial on top, and then all of our x1 to x6, all of those numbers here, those 2's have to be on the bottom getting multiplied. So it's 2 factorial, 2 factorial, 2 factorial, 2 factorial, and one more. Okay, so we have all of that. And then at the very end of our work, we have to write out our probabilities raised to whatever the x's are as if they were powers. or exponents. So we're going to start off with the probability being your big numbers, the 0.13, and then it's going to get raised to the second power. And then we're going to do 0.13, 0.13 to the second power, and then 0.14 to the second power, 0.16 squared, 0.2 squared, and 0.24 squared. Getting a little antsy there. Okay. Get that cleared up. We'll continue. All right, so now we're ready to do the math. So we need to do 12 factorial divided by 2 factorial times 2 factorial, so on. Now it turns out 2 factorial is just going to be 2, so we're actually able to do 2 times 2 times 2 times 2, like 2 to the 6th power, basically. So we're going to do 12 factorial in our calculator. And divide it by 2 to the 6th power. And you're going to get 7,484,400. And then you're just going to multiply all of this with the 0.13 squared and all that. You're just going to multiply that all out, okay? So you're going to take your answer and multiply by 0.13 squared times 0.13 squared times 0.14 squared times 0.16 squared times 0.2 squared times 0.24 squared. And when it's all said and done, we're going to round to 4 decimal places. You get 0.002. And since it's 4, 7, that 7 is going to cause that 4 to round to a 5. And that'll be our final answer.